Let's begin by reviewing the identity property of addition and of multiplication. Addition and multiplication each have an identity, but division and subtraction do not. An identity is just a number that when you, for example, add any number plus the identity, you'll get the same number that you started with. So let's say we have an x, okay, just any random number, and then we're going to add the identity to that, and we're going to get what we started with, x. Okay, so what's the additive identity? What number do we have to add to x to get x? All right, 0. Great. Now what about the multiplicative identity? What number do we multiply x, any random x, by a number, and we just get the same number that we started with? 1. Great. Okay. So we have an additive identity and a multiplicative identity. Okay. So that means when we add 0 to any number, get the same number we started with, and multiplication when we multiply by 1, we get the same number that we started with. Okay, so actually the identity property does work for subtraction and for division, but maybe some of these others don't. So the next one is the inverse property. It's based on the identity. That is to say that addition has inverses, and so does multiplication. What does it mean to be an inverse? That means if we have a random number, okay, so any number, it has an inverse if there's something that we can add. There's something that we can add to this number to come out with the identity. What's the identity for addition? 0. Okay. So is there something that if we add to x, we're going to get 0? Let's use real numbers. Okay. So let's say we have an integer, 3 maybe. Okay. What do we need to add to 3 to get 0? Negative 3. So 3 plus negative 3 is 0. So x, if we had just an arbitrary x, x plus negative x is 0. So there's an inverse. X and negative x are inverses of each other. 3 and negative 3 are inverses of each other. Multiplication also has inverses. So if we have an arbitrary x, is there something that we can multiply this x times to get the multiplicative identity? What's the identity again? 1. Okay. Is there something that we can multiply by to get 1? So let's use integers again. Let's try 3. What do we need to multiply 3 by to get 1? Is there an inverse for 3? A multiplicative inverse? Yeah, 3 times 1/3, right? 3 times 1/3 is 1. So 3 and 1/3 are inverses of each other. So for any x, if we just take the reciprocal, we will get the multiplicative identity. Okay, so the additive inverse is the opposite of a number, the negative of a number. The multiplicative inverse is the reciprocal of the number. All right, great. Next one, commutativity. Commutativity tells us that we can add and multiply in any order. This is definitely not true of subtraction and division, right? You can't subtract things in any order and get the same number. 2 minus 3 is not the same as 3 minus 2. But it is true for addition and multiplication. You can add things in any order. Okay, 2 plus 3 is the same as 3 plus 2. And this is the property of commutativity. It's also called the abelian property. Abelian, named after Niels Henry Abel. He was a famous mathematician, and he worked a lot in algebra. This is an algebraic property of group theory. So Abel, abelian, it's commutative. All right. So what is the addition property of commutativity? For the commutativity property of addition, we have a, so for any arbitrary a plus b, any real numbers, equals b plus a. Okay, you can add things in any order. I like to think about this as somebody has to make a commute to school or commute to work. You go there, you go to work, come back. Okay, so go there and then come back. That will help you remember this property. Multiplication, same thing. You can multiply things in any order. Any arbitrary A times B is going to be the same as B times A. So like 5 times 2 is 10, and 2 times 5 is 10. Same thing. All right. Next one, associativity. Okay. Associativity is the idea that if we have 3 things that we're adding together, so maybe we're going to add 1 plus 2 plus 3, we can add the first 2 and then the third one, or we can say 1 plus 2 plus 3. Either way is fine. Okay, so first you could add the 1 and the 2 and then the 3, or you can add the 2 and the 3 first and then the 1. Okay, just saying that how you add up doesn't matter. Okay, so this is true for addition and multiplication. The property would be for arbitrary numbers, A plus B. Okay, any A plus B plus C is going to be the same as A plus B plus C. And for multiplication, A times B times C is going to be the same thing as A times B times C. And this works out. Let's think about it in the case of addition one more time. 1 plus 2 is 3. 3 plus 3 is 6. Over here we get 2 plus 3 is 5, and then plus 1 is still 6. Okay, so this is associativity. If you want to try to remember this rule, think about it this way. The B is friendly. Okay, the B likes to associate with different kinds of people. The B associates with A, the B associates with C, but the A and the C, they're not so friendly. Okay, so just think about the word associate, and like the B likes to hang out with the A and the B likes to hang out with the C. Okay, it's pretty friendly. Okay, hopefully that'll help you remember. Distribution. Okay, this is probably the one that you know the best. We use it all the time. Distribution. Notice that distribution is not a property just of addition or just of multiplication. This is a property of multiplication over addition. Okay, multiplication over addition. So this property involves both at the same time. So this is the property. I know you're familiar with it. If we have A times B plus C, notice we have the multiplication and the addition. A times B plus C. Then we can distribute this A, and we get A times B plus A times C. Okay, so if we have times right here, well, and then addition in the middle, we can have times, times, and addition in the middle this way. Okay, and this works. Let's just do a quick example. I know you already know this. If we have 2 times 1 plus 4, this way we would do what's in the parentheses first, according to order of operations. And so we'd get 5, and then 2 times 5 is 10. If we do it this way, it would be 2 times 1, okay, if we distribute the 2, plus 2 times 4, all right, and that would be 2 plus 8, and 2 plus 8 is still 10. Okay. So in the case of actual numbers, distribution definitely works out. It works out with variables as well. And you'll see, and I'm sure you've done it in the past, we need distribution when we deal with variables because we won't be able to work inside the parentheses because we won't have like terms. Okay, let's move on to some examples. So based on what we just saw, decide whether the statement is an example of commutative, associative, identity, inverse, or distributive property. So that was the one that we just did, right? This is 3 times x plus y. And notice we now have 3x plus 3y. So this is distribution. Okay, let's look at number 2. evaluate the expression if P is -2, Q is 2, and R is -4. Okay, so we have an expression here. What does it mean to be an expression? It's a mathematical or an algebraic phrase, right, with no equal sign. So this expression, notice it doesn't have an equal sign in it, okay? So it's an expression, but we know what P, Q, and R are. So let's go ahead and plug them in. Remember when we're plugging things in to use parentheses. So first Q, Q is 2, 2, plus R is -4, and then Q again is 2 minus P, which is -2. And this is why we use parentheses when we plug things in, because we have situations where we have a minus a negative, and that might get confusing. So if you use parentheses, then you're fine. Okay, so let's simplify. We're going to simplify the numerator and the denominator separately, and then we're going to reduce. Okay, so 2 plus -4 is -2, and 2 minus -2 is the same thing as 2 plus 2, which is 4. Okay, reduce this, get -1/2. Great. Let's move on to number 6. Okay, fill the blank so as to produce two equivalent statements. We want the arithmetic statement, A is greater than B, and we want the same thing as a geometric statement. Okay, so geometric, think visual, okay? So visually, what is this saying? A is greater than B. So we would be talking about a number line. Okay, so remember on a number line, we have 0, we have positive numbers, okay, 1, 2, 3, negative numbers, -1, -2, -3, okay, something like that. If we say that A is greater than B, if you're not sure, pick real numbers, okay? Pick numbers you can understand. So let's say A is greater than B. Instead of A is greater than B, let's say 2 is greater than 1. Okay, these are numbers we understand. 2 is greater than 1. What does this mean visually on a number line? It means that 2 is to the right of 1. Okay, 2 is to the right of 1. So if we're saying 2 is to the right of 1, that means that A is to the right of B. So you can look at these options. A lies to the right of B. That's the right one. All right. Good. If it was the second one, lies to the right of or is equal to B, what would be different? It would look like this, right? With a little line under the inequality symbol, right? That would be equal to. What about lies to the left of B or the same point as B? Okay, so for left, we would have to have the less than or equal to symbol, right? Less than or equal to. This would be lies to the left or is the same as B. And then for the last one, A lies to the left of B. That would be strictly less than B. Okay, but we have this one, so our answer is A. Okay, last one. Let's look at number 8. The wind chill factor is a measure of the cooling effect that the wind has on a person's skin. It calculates the equivalent cooling temperature if there is no wind. Determine the magnitude or the absolute value of the difference between the entries in the table shown to the right. That is, subtract the two entries and find the absolute value. Okay, so they tell you pretty much exactly what needs to happen here. We have a table, okay? These are different temperatures, okay, 0 degrees Fahrenheit, all the way up to 40 and all the way down to -40. And then these are wind speeds in miles per hour. And this chart gives us the wind chill information. Find the absolute value of the difference between the two indicated wind chill factors. So absolute value, okay, absolute value looks like this. Difference, that tells us subtraction. All right, so what are we subtracting? Wind at 15 miles per hour with a -40 air temperature. Okay, so 15 miles per hour with a -40 temperature. Okay, so that's -71. and wind at 15 miles per hour with a negative 40 air temperature. So this is the exact same thing, negative 71. Okay, so we are going to subtract these, negative 71 minus negative 71, and then find the absolute value. Okay, so how do we subtract two negatives, right? Make a positive. So negative 71 plus 71. Okay, so that would be the absolute value of 0. And what does absolute value mean again? Okay, it means the distance away from 0. So how far away is 0 from 0? It's right there, right? It's right on top. So the absolute value of 0 is just 0.